Hello, my name is Rabi. In today's video, I'm going to show you how to deploy a microservices application on Kubernetes kind cluster. The reason I'm making this video is that I watched recently a video that explains the same code, but they are running on EKS, AWS EKS, and a lot of people in the comments were asking if they can run it on locally on their machines to avoid paying cost for this. So the way I did it is using kind cluster. So I'm gonna go through the README file first quickly and then jump right into VS Code to deploy the application. So this is not intended to explain the code itself, but just how to deploy it simply on your machine. So to do so, I'm using DevBox, which will make it very easy to reproduce the whole environment by installing those prerequisites that's gonna be used within your environment, like pSQL or Mongo SH to access your SQL Postgres database or Mongo database. Also installing the kubectl and kind everything needed to deploy the application is specified in the devbox JSON file, so it will be installed automatically to be exactly the same as the one I'm explaining. Also, I'm using a task file, which is a task runner. It will make it so easy to show how the code is deployed instead of having to copy paste multiple commands. You can just specify those commands in a simple task and then just run the task and it will run everything for you. So it just makes it easy to document and explain. So our project, after using DevBox and task, can easily be deployed using just 4 commands. Just you create the cluster, the kind cluster, and then you install the Helm charts, Postgres and Mongo and RabbitMQ, and then you deploy your microservices, and finally just doing some tests, uploading a file to be converted, and then downloaded the MP3 file. So my cluster consists of 3 worker nodes and 1 control node. You don't have to have this. You can just have 2 nodes or 1 node, 1 worker node and 1 control node. But this is how I did it. And if you don't know, kind is, as the name implies, it's Kubernetes in Docker. So all your nodes would be deployed as containers, and the image of the container that's used by kind will be pulled automatically from Docker Hub. So you don't need to worry about this. All you need is just to deploy the kind cluster using kind create. And while creating this, you just need to specify some ports, because in our project we need to access the database to run some SQL queries or access the RabbitMQ to create the queues. And all you need is just to expose those ports so that you can access them from your local machine. And I'm gonna show you how to do this in the kind configuration files. So these are the commands you need to do. Very simple, just switch between directories and run the task files. The task is inside the task file. And just going through the workflow here, just as a kind of reminder how things working here. So first, the user will create a request like this, specifying his username and password. This request will be intercepted by the login endpoint in the API gateway. It will consult the Postgres database for the username and password. Once authenticated or verified, it will create or generate the GWT and send it back to the requester. Then, using this GWT, you can upload your video here. You specify the video and the token just generated and send it to the API. The API gateway will, the upload endpoint will intercept this request and will do two things mainly. First, it will store this video to the MongoDB and get the file ID. Once it got the file ID, we'll send it to uh, or publish it to a RabbitMQ called video. Then the converter microservice is listening or consuming this video RabbitMQ queue, and will do also two things. One, it will convert the video into MP3 and store it to the MongoDB. Also, it will publish the FID of the converted MP3 file to a RabbitMQ queue called MP3. The notification service is consuming this RabbitMQ, and it will just take this FID published in the queue and will send an email to the user. Once you got the FID in the email, you can use it to download this MP3 by specifying here the FID and also using the same token. And you can send the download request. It will be intercepted by the download endpoint in the gateway, and it will get the file using the FID and send it back to the user. So this is mainly the workflow, how it's going. But I just added a very simple modification here because normally you will have to, as you see, you will have to upload the file and wait it to be sent back to your email, copy this FID and paste it back in your request. So it broke the automation workflow. So what I did is I created another RabbitMQ temporary queue and make this converter to not only publish to the MP3 queue but also to this temporary queue, and this temporary queue is consumed by the API upload endpoint itself, so that when you call the upload endpoint, it will return back the FID automatically. You don't have to go back to your email, get the FID, and then copy and paste all this. No, instead of this, the upload endpoint once uploads the video and the video converted, it will return back the FID, which can be read and used in the download endpoint. um, I think that's all I need to explain in the architecture or the workflow. And once you're done, all you need if you wanna destroy all your environment, you can just use a task to delete the cluster like this. This is the original code. If you wanna go check it, or if you want to deploy it on the EKS. So right now, let's jump into the code and deploy our application. Um, let's copy this first. Let's clone. Open folder. Mm, ah, I need to close the repository. letter. Yeah, by the way, I'm using, would you like to open Find repository? Yes, open it in VS Code. So I'm using, if you're using Windows, the terminal process failed to launch, starting directory command installation does not exist. What's this? Separate. I don't know what happened, but it looks like it's downloaded successfully here. So let's open a terminal. Yes. So I was saying I'm using Docker. I'm using Windows subsystem for Linux, WSL. And if you are gonna use the same, make sure you have Docker desktop installed, because this is where our cluster will be running. So let's go through the main directories here. But first, before forgetting, let's check our branch, git branch main. So let's switch git check out feature return. This is just to have this extra queue so that we can show everything automated. Now git branch just to make sure. Yeah, now we are in the feature branch, and we have three main directories. First is the kind installation. We have the Helm charts. We have the services. Let's go through them one by one quickly. First, the kind cluster. So in each directory, we will have a task file. So let's check this task file quickly. And so if you notice here, we have as the first task is to create a cluster, and it's just a very simple command, kind create cluster, and you specify the configuration file. Let's check the configuration file here. Very simple configuration file. Just you specify that you need a one control plan node and a three worker node. And in the control plan, you specify here the ports that you want to expose to your local host so that you can access the MongoDB from your local host, or access the RabbitMQ to create the queues if you want to create them manually. So that's very simple. Here you just create the cluster, and I added some other tasks. You don't have to run them, but just for your information. If you want to create a namespace, if you want to delete the namespace, or at the end when you finish you want to delete everything, you just delete the cluster. And also, deleting the cluster doesn't mean you deleted the Docker images. You need to delete them manually so you can run this task here. Now let's go do this cd kind, and you do first let's switch to our environment. Make sure you install devbox. So I already installed it. You can check the readme file, and to switch it to your environment you just need to devbox fill. That's all you need. And what is this gonna do is gonna install all the requirements here. So Mongo SH or kubectl, all the requirements that you would have to do those manually is gonna be installed automatically for you. Now we have our environment ready for us with all the commands we need, like Mongo or kubectl or kind. Everything is installed for you here. Let's close this to make things clear. And now if you do t T is just alias for task, and also this is specified here in this div box here. not luck, sorry. This debug JSON here. You check here, you'll find me adding two aliases, T and key for kubectl and T for task. Those alias is gonna be done for you once you switch to your environment. So now you do T, you will see all the tasks that you can run. And from here, all you need is to just create the kind cluster by running the first task, which is kind create cluster. Before doing so, let's check the containers we have. You might need to install some extensions for VS Code to show this. So here, if you notice, we have only one container Jenkins. This is not used here. And we have those images. You notice there is no kind image or anything here. So now let's run our command here. So to run this command, all you need is T and kind 01 create cluster. This is creating your cluster, which consists of um, one control node and the three worker nodes. Note what's happening here. Yeah, now you see the cluster is being created, and also images should be shown here. Maybe you need to refresh this. Yes, our cluster is done here. Engine X, Docker. I'm not sure why the images are not shown here, but they should be here. You go to images here. Yeah, you see the kinds node here installed and downloaded for you. Yes, UI is not showing here. Do I need to expand this? Anyway, so right now your environment is ready with the kind cluster, and you can show this using the git nodes. Yeah, we have three worker nodes and one kind control plane node. Now, as simple as this. Now we switch to the other directory, which is Helm directory, to create our Helm chart, to run our Helm charts, which will create the MongoDB, the Postgres, RabbitMQ. Exactly as before, we have a task file here, and in this task file, I'm using a wrapper task instead of having to run those tasks one by one. I created another task called install all, which will go through all the tasks and install them for you. So all you need is just to run one task, but you still can run them individually if you want. So it's gonna install the Postgres, then run the scripts to create your database and tables, and then install the Mongo database, and then install your RabbitMQ, and then create the video and the MP3 queues, and finally just list all the created charts. As simple as it's. Um, those tasks are all, you can go through them here. This is why task file made it very simple and also documented. So all you need here is to just list our tasks here. Units, same tasks shown before. And to install all of them, all you need is to specify the helm install all, and that's it. It shouldn't take long, but in case it gives any error, that means maybe it tries to create tables or create the queues while the RabbitMQ or the database were not yet implemented. So all you need is just to run the command again. That's it. Don't need more than this. You see now the table is created, and it should be now creating the queues. There you go, done. So the queues are created and database are created. Let's list all the charts. Um, have list uh, dash a. Yes, there you go. You have the Mongo database, the Postgres, the RabbitMQ. That's all. Now, the third part, we switch to the source directory to launch our microservices. The only thing that you need to do is you go into the notification service, to the manifest, to secret, and you need to specify your Gmail password. If you don't know how to create a password, add password, this is explained in the README. So go through the README and create one. So you need to create a password here so that when the application converts the file into MP3 and wanna send you an email, you got your password here. So I'm gonna pause the video for a second, adding my password and come back. So I just add my password in the secrets file, and now let's check the tasks file again as usual. And you check here. I also have a wrapper, has a wrapper that will go through multiple tasks: install, auth, install, converter, and gateway notification. It will install all of them just using one command. So here we switch it to the directory and we do T. You got all the commands here. All you need here is to just T svc installed and all. That all will install all the tasks for you. So what is this gonna do? Basically, let's go through one of this uh, microservices installation. So what it will do, it will build your container. It will log into your Docker Hub account. Make sure you uh, make it easy for it to log in by specifying your username and password. And then it will push the Docker container image to your account in Docker Hub. Now, once the kubectl apply needs this Docker containers, it will pull them from your account. Also, make sure you make them public. Now we're done. Everything is run. Let's make sure that we have everything up and running. So, okay, git puts. Okay, let's switch to our namespace. Cube ns my project. Yeah, switch it to the namespace. By the way, make sure you check this environment variables, and if you need to change any of those, feel free to do so. Otherwise, you can just keep everything as is except your email. You need to specify your own Gmail account so that you can get a notification on your email. That's the only thing that you must specify. Going back here, we switch it to our namespace. So now we can get what's here. Yeah, everything is running and look good. Now the last thing that we need to do is to test. So I created another wrapper task here. Uh, yes, here. So that wrapper task will call another task, API login and API upload, and if the file ID is there, it will run the third task, which is download. So basically, it upload a file and it logs first and then uploads the file and then download it. Let's check this assets here. You notice here, this is the video we need to convert to MP3. And once converted, you should see converted and downloaded, you should see MP3 file here. So all you need is T API test all. This is the wrapper task that has the three tasks. And let's check our Gmail first. Uh, here, there is no uh, Gmails yet. So let's run this command and see. Here we go. Let's check this assets. You will see this video MP3 and here we go. Let's check if we got a notification. And yes, we got the notification. So that's all. Hopefully, guys, this was helpful, and let me know if you need any help implementing this. Thank you.